we will discuss about basic concepts of sampling. What is sampling? Sampling is a statistically guided, well-planned technique for collection or selection or the recruitment of observations or study subjects. Strategy is dependent on study objectives and other limitations. Samples must truly represent the entire population or range of observations. So these are the four most important criteria for sampling. So while sampling is done, everyone should follow these four most critical uh, things. Sampling is basically used for research, surveys, or decision making for policy implementation. One simple example, sampling is being done to study whether a pH change in the soil can change the grain size. This type of research, important for agricultural science, needs sampling. Another example, what is the most frequent feature of any type of cancer? Let's suppose lung cancer. So sampling is needed to find out the frequency of most common symptoms. This is an example in clinical sciences or medical sciences, you can say. A sampling done by any multinational companies, like you can say, um, you know, mobile internet connectivity. Simple. You can say certain private telecom companies. They do survey to find out what is the volume of data used by students in a particular city. So these are important for policy making. These are important for decision making, policy making for healthcare systems, economic studies, public health research. So in all these, reason, sampling is very important. So let's see how these 4 points can be taken care of while sampling is being done. A statistically and biologically guided, well planned technique. So while doing a sampling, it should follow a statistical method, a sound statistical reasoning behind that, and a biological relevance. So whether a sampling would solve a certain problem which is biologically relevant or not. So first we need to identify the target population. That means which population we should study. The population living in the villages or population living in the urban region, or students, or people who are doing job, housewives, or actively active individuals doing jobs. So these are the target population. Or observational interval. So suppose you are doing a sampling of certain microorganisms or certain observations during in vitro studies. You need to find out the interval of observations. You need to find out the sampling technique, which technique you have to use. You have to identify whether the number of samples are statistically relevant, significant or not. So in this picture you can see in the left hand side panel, from a whole target population that is marked as a red circle, you have selected only few, let's say 6 individuals. So these 6 individuals are samples taken from the target population. So this is target population and this is the sample. And there are array of techniques which can be used to find out these samples. Samples should follow a statistical distribution, a normal distribution that should follow this kind of bell-shaped graph or a Gaussian distribution. Collection or selection or the recruitment of observation or study subjects. So you can see that red dots and the gray dots. We have selected some individual from the whole population and marked them as red dot. So these are having certain feature based on which population are being screened and certain individuals are recruited or collected or selected which qualify as a sample. So if you want to work on cardiac diseases, you must follow a sample which are having cardiac disease and coming from a target population. That means the people should have aged more than 30 or 35 because you cannot find cardiac diseases among juvenile individuals. Certain diseases like polycystic ovary syndrome, you have to take female individuals as target population. You cannot find PCOD among males. If you want to find a disease like Alzheimer's, so to study Alzheimer's, you have to target elderly individuals because Alzheimer's are generally no, most prevalent among elderly individual aged more than 50 or more than 60. So you have to have a target population and you have to select or collect or recruit the observation or the study population from the whole region. The strategy is dependent on study objectives. So which strategy you have to follow, which strategy you have to perform to collect only few individuals, on what reason, why you have to select only few individuals. It depends on the research question, what exactly you want to perform. If you want to perform an observational study to find out what is the most common BMI, what is the most common, you can say, blood pressure in a village. So we have to screen most number of individuals to find out what is the most common blood pressure. Is the population is suffering from hypertension or not? A simple example. What is your research question? Asking. You should ask, what's the sampling frame? You have to ask, what type of statistical tests that I need to perform after collection of data. Are we going to do an observational study or experimental study? After collecting data on frequency, will we only just show the frequency of the most common phenotype, or will analyze it to find out certain biologically important answer? How much time is there? How much fund is available? Is it feasible? Sample availability is there or not? Ethical issues, because you are performing an human related research, so that the protocol of sampling or the downstream study that you'll be performing after doing this sampling, that should follow an ethical guideline. Nothing in biological science on human being you can do without an ethical guideline. So these are the most important thing that would determine the strategy of sampling, how to perform it. A study on certain, let's suppose, you know, fetal growth study. It is not feasible all the time. It is very difficult to perform, because you have to access a fetus, and you have to examine pregnant woman to study fetal growth or fetal behavior. Most of the time these are not ethically permissible. Samples are not available. It is not always feasible. It takes longer time, right? So you have to find out, these are the things like emergencies, health emergencies like coronavirus outbreak. Did we have enough time? No, we had very limited time, limited fund, not always feasible because it is a very contagious disease. So not always you will get the manpower to perform the study. Okay, so based on these very important parameters, sampling method need to be determined. Ultimately, it should give you a best sampling strategy, most efficient sampling method, statistically correct, and replicable outcome. The outcome you should get must be replicable. So if you have performed a study in Indian population, and if I perform the same study at the same location, the outcome should be replicable. I should get the same outcome. I should get the same result. Then only I can say, yes, the study was correct. That was done before. So these are the most important thing that determine which strategy I have to use to do the sampling. Then samples must truly represent the entire population or range of observation. So look at this picture. Look at this picture. So these three individuals were selected as a sample from the whole population or the sampling frame. These three individuals must represent the whole population. What do you mean by must represent? That means the mean should be same. So if I say the mean age of a population is 24 years, so the sample that I've taken, their mean age should be also 24 years. Distribution of variance. So if I say the lowest age and the highest age, or the height, or the BMI, or no blood pressure, or anything, any parameter, food intake, physical activity. So you should have all the variation. The distribution should be similar. This is very difficult to achieve basically, but a good sampling method will always comply these 4 points. The mean should be same. The distribution of variance must be similar, representing all the variations. Suppose you are doing a sampling for genetic variation and you did not collect some variations which are present in the population but not present in your samples, then your sample is basically not a true representation of the whole population. Understood? So you have to decide how to do the sampling so that the sample should have all the variations, must follow the same distribution, and preserve the kinetics and the dynamics of the population. For example, the rate of mortality. The rate of mortality due to certain disease, let's say cancer. If in your population the mean age, or you can say the median age of the death is 65 years, your sample should also have the same value. Okay, the age of disease onset, survival rate, death rate, birth weight. So these are the different kinetics and the dynamics of a population, and the sample should have all these variations preserved in them. Then only we say it's a true representation of the entire population or the range of observation. So whatever observation is present in the population should also present in your sample, though your sample is much lesser than the whole population. Let's suppose you have selected some individuals from the city of Delhi. The Delhi population is near to 1.5 150 lakhs individual, but your sample size is simple 15,000. But those 15,000 individuals should carry all the representative units from your whole Delhi population. Obviously, depending on which type of study you are doing, what is your observation? If your observation is smoking and health outcome, so you should follow what type of smokers are present in Delhi: passive smokers, active smokers, the frequency of smoking, the type of smoking, etc. A statistically guided, well planned technique should be followed for sampling. So the technique should be scientifically correct. It should not be illogical, it should not be unscientific, it should not be casual, it should be very strict, scientifically strict. That should give a replicable outcome and achievable and ethical. So that you have to decide which technique you have to use for collecting observations or sample for your study. So ultimately, sampling will give you a set of individuals on which you can perform a study. And you do not need to go to the whole population all the time to collect data. So all your data is now present in only few individuals. As I said, out of 150,000 individuals, you have selected only 15,000 individuals, and this is your sampling. You have collected these individuals based on certain sampling technique, and you label them as sample for your study. Your entire study will be performed on these individuals, which can be easily inferred to the whole population, because these individuals are true representatives of the whole population. So which sampling technique to adopt? Follow my next class. Thank you.